Okay, so for cubic functions, sorry, I forgot to record. For cubic functions, you have to keep the full, like 8 or 9 decimal places on your calculator, otherwise it won't get to 0, right? So I'm just warning you now, the higher power, so usually we kind of warn you is that keep more decimal places. So just watch out when you do the homework, you have to keep a bunch more. For example 2, we're asking you to use a centered interval. Okay, so centered interval, we got those words in our head now, right? Preceding, following. Centered is more useful, right? So centered means you have the 2 points on either side. This one here, what was this one called? Difference quotient. Yep, so difference quotient is this method that we have up here. If I use a centered interval, so see with the difference quotient, we had M1 and M2. We had everything that there, all we had to do is compare M1 and M2, etc. Here, if I use a centered interval, I don't have M1 and M2. Remember, a centered interval just takes 2 points and then just makes it into a secant line. There is no M1 and M2. So then how do I verify if it's a max or min? Then I have to go back and do the whole question again. It seems wrong. So to verify it's a max or min when you use centered interval, then all we're going to do is we're going to check 2 points on the side to see whether or not it went up or down. So I'll show you that way. So if you're asked here for a centered interval, we're going to have to check some points because we don't have M1, M2. Okay? So, and I'll just put that in brackets. So we must check the points since we don't have M1, M2. Right? So the method above, the difference quotient method, we have M1 and M2. We can compare the slopes. Slope up, slope down, it's a max, right? Here, if I use a centered interval, there's no M1 and M2. So then you're like, wait, I have to do the question twice? No, I'll show you how to do it. So if I do a centered interval, remember centered interval is this. M equals, and we're going around the point 3,1, right? So this is the point 3,1. And we're going to do F at 3.01 minus F at 2.99. A little before, a little after. And the difference here is 3.01 minus the 2.99, so it'll be 0.02, right? So we put this in. You don't have to show me the substitution. That goes for these guys here. You don't have to show me that if you're like, it's making me worse copying it. Some people are like, I need to copy it in order to calculate. Some people are like, I have worse problems copying it down. So if you don't want to copy this step where I'm showing the 3.01, I will let you skip to the next one. I need to know what the value was though, so I'll show you. So if you need to, right, if it helps you, show this. Right, so I'm doing this part in blue. Okay, if you think that's actually worse for you, I will accept. Again, you don't have to skip the steps, but some people are always asking me, it's okay. I will accept this next step where you show me that you show me the formula, what you plugged in, and if you go 0. I think I get 0.9999. 4 nines, is it exact? 3.0. Yeah, I get exactly 0.9999. Right, so I got exactly that. And then here, so if you show me this step, and then you show me, yes, I got this number and this number, that's okay. Okay, so if you choose, like this makes you more inaccurate, copying it down, then you can show me this. Some people like this line because when you're punching the calculator, it makes more sense. Some people are like, I can't, like, miscopy something more, so I need to see those at minimum. That over 0.02, that ends up obviously being 0. Right? So I go, okay. So therefore, it's a max or min. So use an algebraic strategy to verify it's a max or min. So therefore, max or min since m equals 0. So I know it's a max or a min. But then for part B, it says check points. Right? So it's actually walking you through the method. So I establish it's 0, which means it should be a max or a min.
Yes, do we have to check 2 points or can we just check 1?
You do have to check 2 because it could be continuing upwards. So it could be a deceptive max min, right? So perhaps you got, say, a 0 and it went like this, right? So you got a 0 there. We'll talk about those guys later on. But yeah, what if you get like it's a deceptive one? So you want to check on the sides whether or not it was heading up and down. So what we're going to do is that if we have a maximum and we know that that point is there, if I check a point here, right, and I check a point here, so point 1 and point 2, and I compare it to my point here, these 2 points should be lower than that point in terms of the y value. So say this was, say, 2, 9, as long as these 2 points are lower than 9, then it's a maximum. If they're higher than 9, that means it headed up and it's a minimum. So let's try that now. So we're going to try F. So check points on either side to verify it's a max or min. Okay, so I'll say may be a max or min. Since m equals 0, we're going to check that. And then here, F at 3.01, which we have here, right? So again, use your calculation from above. We have that 3.01. We calculated it. Okay, so we did it here. So again, it's not going to take more calculations. It just says what part can I pull from. So I have it here, equals 0.9999, right? And then F at 2.99 is also 0.9999, right? You could also just say, right, that F at 3, I know, is at 1, right? So this part here, all of this information is really important. If you wanted to, you could just write the conclusion, which is that F at 2.99, right, is less, and this is bigger, so F at 3. So F is greater than 2.99 and also greater than F at 3.01. So you can use one of these nice inequality symbols. So look, F at 3 is bigger than 2.99, and it's also bigger than 3.01, so you can state it this way. So some people say, I like to just write the values and say therefore, right? So you can say therefore maximum, okay? Or you could write it this way and say therefore maximum. You're saying this is higher than those 2 points, and what is showing is that, look, this is F at 3, right? And these 2 points here are below it. At 2, this is at 1, and these 2 are below it. 0.99, 0.99 on either side. Yep.
So the points 3 to 1 are like the origin?
Yes. Yeah, it's either going to be the vertex. Yeah, exactly. So the 0.31 is either your top point or your bottom point, and you're just verifying if it's a top, these 2 are below it. If not, it would be at 1.0001, which would mean it would be the bottom. Yeah, so compare it to your 0.31. Whichever point I start you at, you're going to compare the 2 points. So again, it doesn't require a lot more calculation. You can phrase it. Some people like to use the values and say, well, this is below this, therefore it's a maximum, so you tell me the values. Or you can just use the inequality symbol saying this is higher than those 2, therefore it's a maximum. Anything else?